Okay, hi everyone. Good morning. So now we are going to continue on our chapter 2, the theory of spectroscopy and the UV visible spectroscopy. All right. So previously you have looked into the introductory part of analytical chemistry, the differences, the definitions of what is analyte, what is matrix, what is sample, and also you have looked at the different kinds of methods that are available, the standard method, the general method, and also the cookbook method. Okay, and also you have looked at the different kind of sampling for solids, for liquids, and for gas. And you also have looked on the sample storage and sample preservation method. And lastly, you also have looked at a couple of calculations. Okay, so now after all those introductory part, so now we are going to look at the instrumentation part. Okay, so uh, let's think of it this way. Okay, you have learned about the whole process throughout chapter 1. Okay, so when you do sampling, you do your storage, you do your preservation, and how are you going to find the method to analyze it back at the lab. You go to for the gold standard. If there is no the gold standard, then you go to the general method, or if not, you go to the cookbook method. Okay, and then and out you're going to do reporting. Okay, so now we are going to focus on the instrumentation part. Okay, so the instrumentation part, you also have learned that we have two types of instrumentation: spectroscopic instruments and also chromatographic instruments. Okay, so now we are going to look at the spectroscopic instruments. Okay, but first we need to know about the theory of spectroscopy, and also the first example of a spectroscopic instrument, which is UV visible. Okay, all right. So now, first of all, in the if you can see my slide, you look at this slide. It says that who killed Napoleon, or should we say what killed Napoleon? Okay, it has been suggested that Napoleon has suffered and died from arsenic poisoning due to this during his imprisonment on Saint Helena's Island. So basically, how can we know that he has been poisoned by arsenic? So basically, from this situation, you can say that okay, just take a sample from him and then go back to the lab and analyze it. Yes, that's it. Basically, the overview of it, you just take the sample and bring it back to the lab and you test for the presence of arsenic. Okay? So, the second one. Okay. Container waste on Casey Island, Antarctica. How can we know that the heavy metals from this container waste leached into the ice and contaminate the ice? So basically, you need to take the ice and then bring it back to the lab for you to test it for any heavy metals leached. Okay? All right. So, this is also another example of it. So the disastrous event of oil reservoir in the Gulf of Mexico affects the bluefin tuna, mostly through the ingestion of these substances. Okay, so as an environmental chemist, you are required to measure the level of plumbum contamination in the fish by instrumental technique. So now you would see that okay, there is a purpose of how of after you have done your sampling, you bring it back to the lab. Okay, now um, you need to analyze for the presence of plumbum. So what do you do? What kind of instruments that you need to use? So you need to be able to justify these things. All right? Okay. So now, as you can see that all of these examples are heavy metals, arsenic, and then you have looked at heavy metals leached from the container, or even the third situation is the measure of plumbum. So basically, now I want it for you to get in your head that usually for heavy metals, arsenic ke, plumbum ke, or any other heavy metals, usually we are going to use spectroscopic techniques. Okay, but mainly in terms of for heavy metals, you can use atomic absorption spectroscopy or ICP, inductively coupled plasma. But all of this instrumentation, we are going to cover it as we go throughout the course. Okay, so basically now we are going to look at the principles of spectroscopy. Okay, why? Because we want to know about what happens when this matter interacts with electromagnetic radiation. Okay, now I want you to get in your head that for spectroscopic methods or spectroscopic instruments is going to be dealing with electromagnetic radiation. Your sample, or in this case your analyte, would have some kind of reaction towards the electromagnetic radiation. Thus, it will be giving out some kind of signal. The interaction of your analyte, for example, plumbum. The interaction of plumbum, have metal kan? The interaction of plumbum with the electromagnetic radiation would give some sort like output. So by measuring those output, we can also measure the concentration of the plumbum that is present inside the sample. Okay, so basically that's the overall idea. Okay, so you need to remember the properties of the matter. Matter ni kita cakap analyte kita lah. Properties of our analyte when it interacts with electromagnetic radiation. So electromagnetic radiation ni banyak. Okay, so basically, what is spectroscopy? Spectroscopy is the study of the property of the matter, which is in this case our analyte, through its interaction with different frequency components of electromagnetic radiation. Okay, each type of spectroscopy uses different light frequency, means that uses different electromagnetic radiation would give some sort of like a different outcome. Okay, if you can see throughout this picture, you can see that these are the types of electromagnetic radiation. We have extremely low frequency, very low frequency. We have radio waves, which usually is being given out by our handphones. We have microwaves. We have infrared radiation. We have visible light, and towards gamma rays. So all of these are radiations, are types of radiations, which if they have come upon our analyte, the analyte would give some sort of like a signal. Okay, dia nak absorb ke, dia nak emit ke. So, benda-benda tu we will look at after. What kind of interactions are we talking about? Okay? Alright. So, remember, the definition of spectroscopy is the interaction of matter with electromagnetic radiation. Okay? Alright. So this is an example lah, of a light going out through a prism, and it gives a different color of light which have a different wavelength. Okay, all right. So why is spectroscopy useful in analytical chemistry? So spectroscopy is useful because it is used for detection. Because as I mentioned before, your analyte would, when it interacts with electromagnetic radiation, doesn't matter what kind of radiation, it will give some sort like an output. Okay, so this output we can measure it, we can detect it through our detector. Okay, so spectrometry pula apa? Spectrometry ataupun kita panggil spectroscopic methods is a group of instrumental methods using spectroscopy. So spectroscopy is the interaction of kalau spectroscopy is interaction of matter with electromagnetic radiation. So when we are talking about spectrometry ataupun spectrometric methods, it is a group of instrumental methods. What are the groups of what are the instrumental methods? We have UV visible. We have AAS, atomic absorption. We have ICP. Okay, so all of this we will cover later, but I want to show you the different words. What does it mean? Okay, all right. So what is a spectrum pula? This is a new term. Okay, prior to this you have learned about what is spectroscopy. what is spectrometric, what is spectrometry, no? So now what is spectrum? So all of these are related. So basically spectrum is the data that you have been obtained from the spectroscopic instrument. So whatever result that you've got from a spectroscopic instruments, it is called a spectrum. So a spectrum ni usually it will have it will be in a plot. Okay, it will be in a plot. Okay, I can just highlight here. It will be in a plot where intensity of energy is detected versus the wavelength. Okay, so basically you can look at this one. So the first one, this is the spectrum for ultraviolet spectroscopy, the UV visible spectroscopy. This is the spectrum for infrared spectroscopy, but we are not going to cover infrared lah. We are going to cover UV visible, and nanti we will look at AAS, ICP. Alright, this is also another type of spectrum. Okay, so basically it is the plot of intensity or the energy that has been detected versus wavelength. Okay, this is in terms of wave number, but basically it's just the inverse of wavelength. Okay, all right. So we have looked at what does it mean by spectroscopy. So now we are going to look what does it mean by electromagnetic radiation. Okay, electromagnetic radiation, there are many types, can we have looked before. So it is a form of energy which the behavior can be described by the properties of both waves and particle. Okay, so basically electromagnetic radiation is a form of energy that can be described in the properties of both waves and radiation. Okay, you can imagine that electromagnetic radiation ni, when we are talking about their wave properties, okay, you can look at this. I believe that you have learned this in physics class, if I'm not mistaken. So this is just a recap for you. All right. So basically, if it behaves in a wave properties, you can detect the wavelength uh, based on the top part here to the top part here. We can see that this is this is a wavelength. Okay, so this is the direction of the propagation is this is towards the right. Okay, so optical properties are explained by describing light as a wave. The interaction between radiation and matter. So now we have itemized what kind of interaction inside from our analyte towards the electromagnetic radiation. Okay. So the interaction might be in terms of absorption, emission, or scattering. Okay. So are described by treating light as a particle. So basically, the light, or in this case we call electromagnetic radiation, would behave in a wave. Okay. Based on this, you can decide what is the wavelength. So wavelength is from the one cycle, from the top part here to the top part, or from the below from the crest to the crest. All right? Okay. So wavelength and frequencies of the electromagnetic radiation. Now we are going to look at into the properties of electromagnetic radiation. Okay, light is characterized by frequency and a wavelength. As we have looked before, when it is in a when we are look at in wave properties, it have a wavelength. Okay, so wavelength tu apa? Wavelength itu is a distance of one cycle. Okay, so from this part to this part is called one cycle. Okay, frequency pula is number of cycles passing a fixed point per unit time. Okay, so it is much more understandable if you can look at in terms of the formula. Okay, it has been given that for wavelength, it is a wavelength equivalent to the speed of light divided by the frequency. Okay, the speed of light is constant, 3 times 10 to the power of 10 cm as negative 1. Pay attention to the to the unit. Okay, if we can rearrange, we can find that the frequency is equivalent to speed of light divided by wavelength. Okay, so this is one type of um, example, one type of formula if you want to explain the wavelength and the frequency. Okay. Electromagnetic radiations consist of quantum energy, which is in terms of discrete packets of energy. Okay, during the interaction with atoms or molecules, which is your analyte, the energy waves behave like a particle. So in this case, you are going to look at the terms energy and the terms photon. Okay, energy has been given that energy is equal to Planck constant times the frequency. Okay, Planck constant, as you look at the Planck constant, it is a constant. Okay, photon is energy equivalent to uh, Planck constant speed of light divided by wavelength. Because the v here, we substitute the v with c, the speed of light over the wavelength. So, based on this formula, the lower the wavelength, the higher the energy. So, this is why if you look at the chart here now, if you look back, the wavelength, the lower the wavelength, the higher the energy. Okay, so wavelength here, you can see that one, okay, for example, if you can see this extremely low frequency ELF, okay, you can see that from from this top part to another top part of the same type, it it is much more lower. Okay, so the lower the frequency, the higher the energy. Okay, the higher the energy that it impose on. So that's why apa? It has mentioned here, that's why, for example, UV radiations from the sun burns. Okay, because it is at a lower wavelength, which means that it has higher frequency. Higher energy. Okay. All right. Okay, this is an example as well. If you can see that the wavelength is much more higher. Okay, and the energy is much more lower. Okay, all right. So now, we are going to look at the type of interaction. Okay, spectroscopic tadi apa maksud dia? Spectroscopy adalah the interaction of the matter, which is in this case your analyte, with electromagnetic radiation. So we have looked at the properties of electromagnetic radiation. There are a bunch of formulas for you to explain about electromagnetic radiation, the wave particles of it, how does it behave, what is wavelength, what is frequency, what is energy, what is Planck constant. So everything have been explained. So now we are going to look at what are the type of interactions of matter with electromagnetic radiation. Okay, there are three types of interaction when your analyte interact with electromagnetic radiation. Okay, there are three. First is absorption, to take up. The second one is emission, to give off. The third one is scattering. Okay, let's look at one by one. Okay, absorption, what I mentioned before, to take up. Okay, so your analyte, okay, you would imagine that your analyte duduk diam-diam macam minding his own business. Okay, for example, plumber, I'm just minding my own business in this fish. When I was subjected to electromagnetic radiation, for example, a UV radiation or even gamma radiation, I have to decide whether I want to absorb whether I want to emit or ever I want to scatter. Okay. So now your plumbum, you imagine that your plumbum analyte just dormant, just okay. I'm not doing anything. I'm just staying put, which means that I'm at the ground level. Okay. Now there is a new term. When your analyte does not do anything, it acts as it is at the ground state. Okay. When it absorbs the electromagnetic radiation that has been imposed on them, they will become excited. Okay, you will imagine that, okay, dormant, tak buat apa-apa, lepas tu bila ada electromagnetic radiation datang, I will become excited. So, I will jump to the next energy level. So, I will become at the excited level lah. So before this, I'm at the ground level, the lower energy state. But now, as I absorb the radiation, I absorb all the radiation inside me. Now I become excited. So I am at the next energy level. So that's why we say here, absorption is the transition or excitation from a lower energy level to a higher energy level because I absorb the electromagnetic radiation. But the absorption, I mean that when I stay at the excited state, it is not stable. I need to go back to ground state. I need to become dormant again. Okay, I need to just be myself again. I don't want to become this excited. I don't want to become high, if I may say. Okay, so when it goes back to the ground level, what should it do to the energy that has been absorbed? It will emit. So the emission is to give off. So the energy that has been absorbed atau the energy that has been absorbed from the electromagnetic radiation, now I want to give it off. So it is a point of relaxation. Kita panggil relaxation. Tadi excitation. So now it's relaxation from the excited state from the higher energy level to a much more lower energy level, which is the ground state tadilah. So that is the differences between absorption or emission. Okay. For some analyte, it will take absorption. For some analyte, it will just become emission. We will look at this later on. But for now, you just need to know what is absorption from ground to up, emission from up to low, from up to ground lah. Okay. Scattering. Scattering pula is the redirection of the light. Okay, I am powerful enough. I don't want to absorb you. I don't want to emit you. I just deflect you to another direction. Okay. Alright. So there are three types of interaction. Okay. So as I mentioned before, tengok. This is a diagram lah, an energy level diagram. So for absorption, your analyte would be in a ground state level. Everything is at a ground state level. But when it absorbs, it moves up. It becomes excited. But it is not, the excited state is not stable. It goes back. So what to do with the energy that has been absorbed? It will emit. So basically these are the types of transition lah. So basically this is we call transition. From ground state to excited state is a transition. Okay, from excited state to ground state is also a type of transition. Okay, so these are the possible type of transition. This is for you to maybe for you to know to just have a read on this. So, but for ultraviolet, you will have much more electronic transition. Okay, what are electronic transition? What are vibrational transition? Okay, so for you to be able to understand, okay, so inside a energy level, it have a rotational and also a vibrational punya energy level. Okay, so you will imagine that E1 is one type, one energy level. E2 is also a type of energy level. Elektronik lah kita panggil. Electronic energy, 2. Electronic energy, 1. Okay? So, basically, when for ultraviolet, it moves from E2 to E1. Maksudnya, dia punya jump is very high. It jumps from one electronic energy level to another electronic energy level. But for infrared, ataupun yalah, infrared lah. Sekejap Alright. So, for infrared, it moves from one vibrational level to another vibrational level, which means that it is within the same electronic energy level. Because inside one electronic energy level, we have vibrational level, we have rotational level, which means that the energy jump is not that high. So it still remains inside the same energy level, but different vibrational or different rotational level. Okay, so this is for you to read only lah. But if you do have this information, it's much more better. Okay, all right. So these are the types of spectroscopy. We have gamma. Means that it depends also on the types of electromagnetic radiation. We have gamma emission. We have ultraviolet. We have infrared. Okay. All right. So basically now we have three types of interaction tadi kan. We have emission, we have absorption, we have scattering. But in your syllabus, it's only going to be focusing on absorption spectroscopy and emission spectroscopy. Emission of radiation and absorption of radiation. So, if you see here, these are the list of examples of spectrometry methods. So for emission, you are going to look at the emission spectroscopy, absorption spectroscopy. So only these two that are you going to look at. For absorption, you are going to look at UV visible atomic absorption spectroscopy. And then for emission, you are going to look at inductively coupled plasma. Okay, only three, if I'm not mistaken. Three. But inside those three, there are some more subdivisions for it. But only three main instruments, right? Two absorption, one emission. Okay? All right. Thank you.